This is the video related to shear reinforcement. Okay, for the beam shown below, assume the in support are of 300 meter and determine the area main reinforcement is required for FCK 30 and shear reinforcement of the beam. Okay, ultimate load is 1.35 into we have the dead load 14 kilometer and 1.5 into live load we have given 9 kilometer. We can calculate it. Then design movement will be WL square by 8. For simply support, WL square by 8, 32.8 into 8 square by 8, and we get the design movement for our calculation. Then we calculate the K M FCK BD square, and M movement we have 259 point something we have. And then we have the FCK 30 B, we have 350 and 475. 475 we have the effective depth that is given. Okay, and we calculate K that is less than 0.167 K limit, so no compression strain is required. And after that we calculate the Z dash, that means Z dash. For Z dash we have the formula D minus 0.5 root under 0.25 1 K by 1.134. We can calculate by lever arm diagram also, but we can calculate formula is Z, and we get the Z dash something like 423.6 mm. Okay, we need to check it is less than, it is less than 9.5, the maximum 0.95, but it maximum 0.95 D is fine. It satisfies the result, and we get the AST is equal to MED 0.87 for Z dash. We get 14.06.6. So we are providing 3H 25 bar. Okay, 25 bar. For Dr. Richard's section with access to 0.0 Eurocode limited 30 minimum reinforcement we have checked. It is 1470 into 100 350 by 400 0.89. It's okay, greater than 0.13% is fine. And now design for shear reinforcement, where the shear reinforcement will be at the section D. Once from this section it will be away from this side, means we need to calculate reinforcement. Reinforcement will be WL by 2 means 32.4 into 8 by 2 190.6 kilometer, and these are diagrams. And we are going to calculate the VED, which is in the support. It is, we have the 300 mm in support, so we got 129.6. we have the movement here, total movement. Then 126 minus 0.19 into 32.4, it will go to the support of the central. It will be at the face of the support. Then we VEDX means it will be at the distance of D, at the distance D. So the VED will, we need to calculate the VED at this distance D, at the distance D, that means 0.1935. and shear range of concrete FCK BRT FCK 339 FCK 30 Newton we have given there. Now we are going to calculate whether our beam concrete will satisfy the shear resistance or not. For that we are going to check the minimum we need to check the shear resistance and design shear resistance. So we have the minimum check for the minimum shear resistance from 6.2 code, and we formula CRDC is given by 0.18. So where is the 0.18? This one is 9.9. Okay. Yeah, here we have the Eurocode member 0 in the Eurocode CRC. It is written like that. CRC is taken 1 by it depends on the national index. So CRC is equal 0.1918. Gamma C is 0.15 for concrete. So we calculate CRDC, and we have for K, its K is given that 1 plus 2 root under 2 divided by 3. It should be less than 2, so it is less than 2 is okay. And we assume that all tensor reinforcement taken past support and answer. So we are going to del 1 is the EST by BWD. It is given, we have calculated it is less than 0.02, okay. And del CPN ED by AC is equal to 0. So now we calculate the P minimum. We calculate the P minimum 0.035 K 0 by 2 FCK. That means P minimum and BRDC, it should be the minimum of with the minimum value. So we have the BRDC, it should mean BM plus K1 plus C BWD. So now we have everything. Now we are going to calculate, put the formula BRDC 0.47, and we only keep the value which we get from up 1. I'm showing how to take the value. If so our VED is greater than 109, is greater than 98.3, so reinforcement is required. So now we are going to calculate now I will going to calculate BRD max of the concrete, okay. Then wait 1 minute. We can calculate the shear resistance by the inclines. Shear resistance by the calculate the shear resistance by the inclined shear by the member. So for that we need to calculate BRDMX. So we have the formula, get the formula from 6.14, and for here B1 is 0. From the Eurocode, here we get the P1 means concrete, P1 1 by X, we get this P1, and we calculate FCD. We calculate from that FCD is alpha C, we get it FCD it is the it is the design strength of concrete. FCD we get it, and BRDMX is equal to BWZ B1 FCD cot theta and tan theta. The maximum value as in X start value will be 21.8 degrees, 8 degree. So we kept the value, and we saw that we check the shear resistance of inclined shear resistance of the inclined member. We got the 463, it is greater than BED, okay, and it's okay. Then we are going to check the two condition, diameter and spacing of link. If BRDC is greater than BED, then we need to provide the minimum reinforcement, and we have from the clause 9.22 we got from where is 2 1 minute 9.4 from here we are for shear reinforcement plus 155 we are going to provide minimum area of reinforcement, and we have formula del W EST BW sin alpha, and we are going to calculate all the as per the formula. SW minimum is 0.0 FCK when YKZ, and we have taken everything, and we have everything, and we calculate the value. Is by that formula we calculate the minimum shear reinforcement. Okay, and max reinforcement of link is 0.75d, 356, so we are provided 300 mm. Okay, and for that is for the minimum case, but in our case we have the BED is greater than BRDC, so we need to go to clause 6. Need to go to clause 6.8. Okay, I'll go to clause 6.8. 3 6.8. Okay, let's see this one 6 ESW tap on sign 1 plus cos theta SW 6.8. I will show you in here 6.8. Yeah, we have the 6.8. We have a minimum vertical reinforcement BRD. Yes, SWZ FYD cot theta. Yes, I have used same formula here. Cot theta. Yes, area of space 100. This one is BRD. Yes, that means we have the value 1093 kilonewton unit resist force upon into 4.75. It is from cal we get the angle. It means it is Z, and we have the design of 500. FYZ is equals to 500 by 1.15, and FYD is equals to 0.475, and cot theta is 2.5, and we get 0.25 AS by W, and hence we provide as 8 m diameter at the trend center to center spacing for shear reinforcement. Yeah, by this way we can calculate the shear reinforcement. Yeah. Okay, thanks for watching. Thank you.